before going to introduce this architecture, let's see some examples of problems where we can shape the data as a sequence in real world. So here you see the speech recognition, also called ASR, automatic speech recognition. So you see that the input is some audio, so a sequence over time, and the output is text, and which is a sequence because there are words. And in this particular problem, in speech recognition, what we want to do is we have some audio with someone that is speaking, and we want to transcribe the text. So again, you see that we are going from a sequence to another sequence. Another example, well, this is machine translation. It's very famous. In particular, the screenshot is from Google Translate. So here, the goal is obviously to translate one language into another. And again, we are dealing with sequences because we are dealing with text. And as we said, text is usually represented as a sequence of words. This is a more interesting example. So you saw this image actually yesterday. So the problem here is caption generation. So it's a problem where given an image, we want to produce some text that describe the image, and this is called the caption. And the problem is to automatically generate this caption. And here you see two examples. The one on the left is this woman that is throwing a frisbee. On the right, we have this giraffe that is standing in a forest. And I said this is more interesting because you see that we have a sequence in output, the text that we want to generate. But if you look at the input, we are not dealing with sequences anymore. Now we have an image. So this is similar to what you have seen yesterday. So you see that we also want to deal with these cases that are mixed, like where we don't have sequence in input, sequence in output, but we can have cases like here where we have a fixed size in input and a sequence in output, and actually even vice versa, like a sequence in input and a fixed size in output. And actually there are many, many examples of data that can be shaped as a sequence in real world. So here, well, we already saw speech recognition, but there is also the opposite problem, so going from text to audio. And you can think of this or what happens with some virtual assistants. Obviously, video is also some field where it's very natural to have a sequence because it represents the sequence of the frames over time. We already mentioned text, we already mentioned the spam filtering and the machine translation. And also there is in the medical field, we can have a lot of data there that can be shaped as a sequence. So we have the DNA, which is a sequence, and we can have the sequence of the heartbeat over time, maybe because we want to find some anomalies. So all of this can be shaped as a sequence, and there is also what we call time series. So time series are basically when we monitor a value over time. And maybe the most famous example is following the value of some stock over time, because we want to predict how it will behave tomorrow. So we have a lot of problems, and we said that MLP and CNN, they present some disadvantages. So we want to introduce a new architecture to solve these problems. Before doing that, let's try to classify these problems so it will be easier to show a solution. So here, basically, you see 5 classes according to the fact if we have sequence or not in input-output. In particular, in the first case on the left, this one that I called one-to-one. Here is basically what we have seen up to now in the previous days. So it means that we are not dealing with sequences, and the input and output, they have fixed size. And one example is object classification. In input, we have an image, so fixed size, and in output, we have a classifier, so we need to pick a label from a list of labels. The next example, one-to-many. So here we are starting to deal with images. So you see that in this particular case, the input has a fixed size, but the output is a sequence. And the example here is this caption generation, which is actually the example we saw before with the image where I want to produce the description. And again, you see that the output is a sequence, but the input is not a sequence. And we have the opposite case just after, many to one. So here, the input is a sequence, but the output is just fixed size. And here we have these problems that we will see more in detail in the third presentation, where we want to classify, for example, an entire sentence, like sentiment analysis, which is basically the problem of given some text, we need to attach a label that represents the sentiment of the person that was writing the text. Now we go to the more generic case. So here we have this many-to-many, which means that we have a sequence in input and a sequence in output, but with one constraint. The number of elements in input has to be the same as the number of elements in output. And the example here is this name identity recognition. I will not give details because this will be our running example in a few slides. The last case on the right is, again, many-to-many, but you see now that I have full flexibility. The number of elements in input is different from the number of elements in output. And we will see that we need these for some particular problems like machine translation, because in this case I cannot have this constraint that I have the same amount of elements in the input-output sequence. So you have already seen this, so we will not talk about this part, so the fixed input and fixed output. In this presentation, we will focus on this case, the many-to-many, where we have this constraint that the number of elements in input is the same as the output. In this case, actually, this case will also include this many-to-one here, because you can see this as a sub-case of this. Basically, I can run this, just ignore all these outputs, and just take the last one. And this will be more clear today, because in the tutorial, you will be asked to approach a problem with this solution here, with this model here. So in this presentation, we will focus on this many-to-many. In the next presentation, we will introduce this sequence-to-sequence model to address the most generic case, so the one here on the right. And again, this case will also include this one-to-many here. We will see that this is basically a sub-case of this one here.